Hello everyone, welcome back to my channel, and this is part 4 of our tutorial series where we are going to understand how we can empower our AI agent with the RAG, right? So in previous part, we have understood like how we can take extract the data from the PDF and upload it to the vector database, right? Now we're gonna learn, or we are going to build the actual logic, or I would say a heart of our AI agent, where we are going to use a LangChain library, which is going to actually do the same magic what RAG offered to us, right? As you can see on my screen, the very first thing which we're gonna understand how we can fetch a relevant chunk, how we can format that chunk to just include in our prompt, then how we gonna just contextualize the query. We're gonna see all those things with the code. So if you haven't watched my previous video, I would highly recommend you to watch the previous one, because I'm going to use a lot of code which we have written in previous part. So let's head into the pie chart. So this is the code which we have written in a previous part, right? So what I'm gonna do, I'm just gonna copy the entire thing, and I'm going to create a new file where I'm going to say end-to-end clearing system. Right. So in this, what we're going to do, I'm just going to copy paste the entire thing. So now what we don't need, I'm going to remove that code, right? We don't want to, again get, we don't want to load the data again, right? So what I'm going to do here is I'm going to just remove all those things. But we really want to do a connection to the Pinecone. So we're going to keep this code here, right? Now, this stats is also not needed because we can verify. So this PDF related code stuff, loading, creating a chunks and all this stuff, we don't need them. And same, we don't need this because through this, we are just loading the data, right? So I'm going to remove all those things, right? But these things we need because these are some configuration which we will be needing. Now, the very first thing which we have to integrate is the few models, right? This is the model which we're going to use, which is Chat Google Generative AI, because as I mentioned, we are going to use okay, right? So this is for first, and then what is next? We want to define which model we want to use, right? So here, what we're going to do, we are going to just, before we actually do that, let's import few more libraries, more classes, which we will be needing. So let me just quickly explain that. String output parser, this is just to parse our output if you want. This is just a chat prompt through which this is just to create our prompt, and we're going to just create the prompt with the template, and we are going to just use this runnable pass-through. I'm going to explain all these three things in a few seconds, right? So these are the library, and what we have done, we just need a model which we gonna hit, right? So for that, what I'm gonna do, I'm just going to copy some code from here. This is the model which we're gonna use, which is Gemini 1.5 Pro, because this is freely available, right? So this is done. So we got all the libraries which we need. Okay, and we got this one, right? The next part which we want is we want to just initialize our LLM for the okay, so we are initializing our embedding. So at the same drive, I'm just going to put this. So I'm just using this chat Google generative AI, which we have just imported. This is where we are actually going to pass in our model name with the API key. Temperature, we can just talk about that attribute. This we can just keep it 0.3. Right? So these are the two things which are important. So now we can just make the connection with the LangChain library chat Google generative AI. Right? So this is done. The next thing which we need is we need to create our vector store through which we are going to retrieve the data. Right? If you remember in the previous part, we also use this vector store to just load the data from documents. But now what we're going to do, we need to retrieve the data based on our query. So what we need, we first need a connection to our index, and after that we have to create this, right? So we can simply say we need a retrieval to which we extract vectors from index with similarity or semantic search, whatever you want to call it, right? So I just created this vector store. Here, if you just see, I'm calling a function which says from existing index. So basically, it's required an index name embedding, right? So we are just passing the minimum required value like index name, embedding, which embedding we use because we need in a similar embedding. Otherwise, it's going crazy, right? And the names, right? So this is done. We have retriever now. The next thing which we need is we have created our retriever. So this is what we have to do. So let me just put this part here, which is very simple, right? So now if you just see what I'm doing here is I'm trying to get the data. And what I'm saying, top K result, and this top K result, let's quickly see if we have defined or not, right? If we haven't, result, okay, so we have defined, okay, we need three records, right? Three most similar record based on the query which we're gonna fetch. So now our retriever is created without any issue. So we use this object and there we have a function call as retriever because that is going to say, okay, now we want to retrieve rather than store the data, right? So this is what the retriever is defined. Now the next thing is what we need to define our prompt, right? This is really important because we know that whenever we interact with the LLM, we have to create the prompt. And that is where this LangChain has a template where you can define a template, a standard template in which you can just put the query. And here what we need to contextualize our query. And that is what we have captured in the flow, right? So we first want to fetch the relevant chunk. For that, we have created a retriever. Format the chunk into the context. So now we have to just create the context, right? So this is where, so for why do we need a context? Because this is the template. So in template, what we are saying, this is hard-coded value where we are saying, okay, you are an assistant knowledgeable about distributed system design because whatever the PDF file you can see, these are the related to the distributed design. Now, answer the user's question only the following context. So whatever the context we are feeding, based on that, you have to respond. So if answer is not found in the context, state that clearly, okay, you are not able to find. Don't make up an information not present in the context because otherwise you will be hallucinating the stuff and we want to handle that, right? So now here, if you just see the curly braces, these are the placeholder where this context variable and the question is going to be replaced, right? So what we need to calculate these, right? So we have to calculate this questions, right? Now, what I'm going to do, I'm going to copy this part because first I have to just quickly this part so that we can just talk about the next one. Okay, so this is just a flow, what we are actually trying to build. Here we don't want this. I think we should be defining somewhere from this point onward because this is the place from where we have started. Right? So we need a format doc, which is, our a helper function, which is pretty straightforward. Whatever the value you are going to feed in, it is just going to join that with the line breaker. So we have two line breakers, right? So we're going to see how the data will look like. So it is actually going to just append these two backward slash n, and we can just gonna see that. So the question which I am gonna ask is, what are the core components mentioned in a high level design for distributed system? Okay, this is my question, right? Now, what I'm doing, I'm creating an input, this is my question. So this is a JSON file where I'm feeding a context, and context has to be come from the data which we have put it in our vector database, right? So I'm using a retriever which we have defined, calling a function name invoke, and then feeding the question. So what this retriever is going to do, that this question is going to be act like a query, and then it will just ask the vector DB, okay, can you just give me the top 3 results which are closer to my question, right? And that is actually going to be just give us a result, and that format docs is actually just parsing this statement with backward slash n, which is just a line because we are just joining them because whatever result we are going to get, that is going to be changed here. Okay, awesome. Now, once we have this input, now we can see we have question and we have context, right? This is my template. What are the two variables which we have context and question. So whenever we want to populate that, we have to just pass in the JSON in which we have those two fields defined. So we have context variable defined and question variable defined, right? So once we just create our prompt, at that point of time, we have to feed in an input. So we have initialized our prompt. Now we are going to just insert. So basically what we are doing here, insert into the prompt. So now we are going to actually create the prompt. And for that, what we have to do, we have to just call this line. Okay. So now what I'm doing here is, let's quickly run this. We can, because now we can see something in output. So this is my input. We can see what input looks like. Okay. So we can simply just do the thing is what we can do. We can just put some. Okay. Then again, you can say, so we can easily discriminate, right? So now what we are doing, if you remember, we are just calling this prompt object, which has an invoke function, and we are feeding an input. So now we are feeding the same JSON where we have context and question, and this prompt object is going to read the template and replace these two values which we have in this JSON file, right? So let's quickly run this and see what happens. So I'm gonna run input. Initialize makes sense. Retriever configure to fetch top 3 result. Okay. Now we can just quickly check what is happening here. So here in context, diverse infrastructure, we can see now the context is created. This is how the context looks like, until this point, right? And then we have a question, the question which we have asked. Based on this JSON file, this is the message which is just getting created with the prompt object. So what we can see, human message, the content. You are an assistant knowledgeable. So now this is the hard-coded part, and then we have a context, right? So if you just see this diverse infrastructure, from this point onward, we have our context, which is just getting appended, right? Okay. So we will just talk about all these gibberish number, and that is something we can just talk about. That. Let's just write the complete. So now what we have achieved, we have just created our prompt with the template where we have a context as well as query. Now we have to make the request to the Gemini model. So that is where we have to just write this language, which is very, very straightforward. So let me just explain you what this LLM is. LLM is which we have defined here, right? This is my object. I am using this class, which is Chat Google Generative AI, and based on your AI model which you want to use, you have to just call the respective library. First, you have to install the respective module, and then you have to call the respective class and feed. And most probably you have to just pass in the model and Google API just to start with, and then you can just use the other attribute as well, right? So this is my object. Again, I'm just using the same thing. I'm calling a prompt, I'm calling an invoke function and feeding in the prompt which we have created in the previous step, right? So once we get the response, then we are going to just use this, which is the same class, if you remember, string output parser, and then we can simply print. So, okay, and then let's quickly copy this. Okay, and then when you actually do something, we'll just one. I think this one is not needed anymore. I can remove that. Okay, so let's quickly run this one more time. Okay, so we would have created our prompt with the context and the question which we have asked, and now it is just making a request, which is a little bit of time. Let's see. Okay, it's a bit longer than expected. Let me just quickly. Okay, so now we can see this is the content, which the provided text mention, this is the actual response which we got, when we make a request, and this string output parts, we just clean up that for us. So now we can see the content, the provided text mention. diverse infrastructure and need for high availability in the context of. So now we can see what exactly happening here, right? The content which we have contextualized based on that, this LLM is trying to answer the question. Therefore, I cannot answer your question based on the provided context, additional blah, blah, blah. So it seems like whatever the context we have extracted, it is not able to provide that, in a proper answer. So what we can in the provided text mention diverse infrastructure and need of for a high availability in the context of distributed system. It also mentioned tools, technology, framework, but doesn't specify any. It doesn't. However, list any core component of high level. Therefore, I cannot answer your question based on the provided question. And that is really helpful because now we know that our system is not capable enough to just answer the question which we have asked, which are what are the core component mentioned in the high level design for a distributed system, right? So basically the files or the content which we have copied and uploaded. So here probably we can ask, what is monitoring system? So I just asked a different question this time, and let's run this one more time. Take some time. Okay, so let's just quickly cover. Okay, so we're making a request to the Gemini. We covered that, pass and return the result to the problem. We covered this. So we just covered all the 5 points which we want to cover in this video. Let's see what response we get. It's a little bit slower. Okay, so now again, let's see what we are getting here. Monitoring is the distributed software design, refers to the continuous process of collecting, analyzing, and visualizing a data about the behavior, right? So now this time we are not getting that response where it says that answer cannot be given, right? So now it has an information based on the context, and now it is not hallucinating. So now we are able to prove that hallucinating is not happening in the RAG based on our data which we fed, and we can control the hallucination. So monitoring in distributed system design refers to continuous process of collecting, analyzing, visualizing data about the behavior, performance, so which is really, really awesome. So we have built our end-to-end working RAG chain, and now we reach to the point where we are going to make more. We are going to add more intelligence, but before doing that, we are going to create a web application rather than, just playing with the code. We will be just asking the questions with the web application. So in our next part, we are going to start building our web application. But before we build our UI, we are going to just, create a modularized code based on whatever we have written so that it can be integrated with our UI without any issue. So that's it from my side for this video. And if you have any feedback and suggestion, please feel free to put that in the comment section. And if you really like this video, please give a thumbs up. And if you feel that, okay, this video can help your friends, colleagues, or your group, please feel free to share with them. And one more important point, if you haven't subscribed for my video, please don't forget to subscribe for my video. Thanks for watching this. And as always, stay healthy and keep learning new things.